What's happening, dogs? Mr. Allen here. We're going to solve this beautiful inequality by graphing here. I got a trinomial, degree of 3. Whoa. Hey, you know what? Looks like we got some things in common here, right? Everything has an x here, and they are all divisible by 2, meaning I have a GCF. Anytime I'm factoring or I'm going to solve some polynomial, I'm going to look for a GCF first to make my life a little bit easier. So let's go ahead and factor out that 2x here, which will leave me with x squared plus 5x minus 6 is greater than 0. But the fun is not over. Factoring, more factoring. We got ourselves a trinomial here. Can anything multiply to negative 6 and add to positive 5? Yes. We'd have positive 6 and negative 1. So I'm going to have 2x still, right? I got to have that. I'm going to have x plus 6, and I'll have x minus 1, because that's going to multiply to that negative 6 and add up to that positive 5. Beautiful. Beautiful. Now I got to solve this thing, right? So first off, I'm going to find my zeros. These are not my solutions. It's just going to help me get there. I'm going to get x equals 0 for this one, x equals negative 6 for that one, and then x equals positive 1 for that one. And I can plot these points. So I'm going to have positive 1, 0, and I will have negative 6. Excellent. Fantastic. Now I'm going to do a sketch. And sometimes with these problems, they say, hey, you need to sketch it and then also solve it, right? So sketching is a part of the problem. Now this is a positive cubic function, which means it'll look something like that. So I got to fit that to this graph. Probably have to get up pretty high here and then whip. All right, so let's do it. Woo! Ah. That was fun. I went a little too fast. The marker didn't keep up with me. All right, there we go. Right? You do need to have the sound effects, okay? Make sure you're doing that, especially when you're taking a test. Be doing that on the paper, right? The kids will love you. Everybody will love you in your class. All right. So now I can answer, when is it greater than 0? Well, it's greater than 0 in this particular spot right here, right? As well as that part of the graph too. So for greater than 0, I'm going to be between negative 6 and 0. So negative 6 less than x less than 0. And then again at positive 1 to infinity. Or I could just say x is greater than positive 1. Nice. That's fantastic. That's one way of writing it. There are other ways. Well, at least one other way that I'm going to go over right now, which would be interval notation. So I will have negative 6, comma, 0. I'm using parentheses here because I'm not including that value, right, of negative 6 or 0, because it's not greater than at that point. It's equal to. If this was equal to, I'd have equal to's under here, and I'd have brackets right here, right? Just covering all of our bases here. Just in case you're like, well, bro, when would I use brackets? I just told you. All right, union. Then we're going to go from 1, okay, 1, not including the value, to positive infinity, to infinity and beyond. So either one of those would work here, right? If it specifies what notation to use, then do that. This is called interval notation. Up top, we got ourselves some inequality, sometimes referred to as set builder notation, right? That's pretty dope. That's awesome. I loved it. It was fantastic. I hope you guys loved it too. And you know what? You guys have a great day. America Freedom, rock and roll, Costco, Riverdog Jenny on the gram, and of course, all the Mr. Allen Maths. Make sure you guys subscribe and do all those things. I'm going to say that like a YouTuber now, right? Make sure you like and subscribe, dogs. All right, see ya.